This video will go over how to solve logarithmic and exponential equations. So for example, solve 2 log 5 of x is equal to log base 5 of 9. We need to get the log by itself to where there's just one logarithm on each side with no numbers in front. Since we have a 2 in front, we're multiplying this logarithm by 2. Remember, that's like having an exponent in the logarithm. Remember, use the properties that we learned about in the previous video. So that would be log base 5 of x squared is equal to log base 5 of 9. Now, since the equations we have an equal sign, that means they're equal. And since the bases are equal, that means the inputs must be equal. So we can rewrite this as just x squared is equal to 9. So x is equal to 3, or x is equal to negative 3. However, remember, since we're dealing with logarithms, remember the domain of the logarithm is always positive. The domain of the logarithm are all x values greater than 0, so we don't care about this. So x is just equal to 3. Alright, let's go ahead and solve this equation for x. Log base 5 of x plus 6 plus log base 5 of x plus 2 is equal to 1. So, if we're adding these logarithms, that means we can multiply them and combine them into one log. So, log base 5 of x plus 6 times x plus 2 is equal to 1. Remember, we can rewrite in a logarithm as an exponent. Take the base, which is 5, raise it to power of what the logarithm is equal to, which is 1, set it equal to the input, which is x plus 6 times x plus 2. So that'd be x squared plus 8x plus 12. So if we subtract 5 from both sides, we have 0 is equal to x squared plus 8x plus 7. So if we factor this down, that'd be x plus 7 times x plus 1, which means x is equal to negative 7, or x is equal to negative 1. However, to determine if they both work, we need to look back at our original logarithm. Remember how we had log base 5 of x plus 6 and log base 5 of x plus 2? The inputs have to be greater than 0, which means x plus 6 has to be greater than 0. And also, x plus 2 has to be greater than 0. This is an and. They both have to work, which means x has to be greater than negative 6. Hold on. X has to be greater than negative 6, and x has to be greater than negative 2. The only one of those x values that works is, the only one of those x values that satisfies these conditions is negative 1. So here's another example. Solve ln of x is equal to ln of x plus 6 minus ln of 4. Before we even start, it might help to figure out the domain so we can figure out what values our solutions can or cannot be. Remember, the inputs have to be greater than 0, which means x has to be greater than 0, x plus 6 has to be greater than 0, and x minus 4 has to be greater than 0. That means x has to be greater than 0, obviously. This means that x must be greater than negative 6. This says that x must be greater than positive 4. Since all three of these have to be satisfied, you can just take all the x values that are greater than 4. That will make all of them work. All three of the logarithms will work that way. So just remember that whenever we get any values of x. So now back to our equation. Since we're subtracting these on the right hand side, we can just combine them into one logarithm and subtract. So we would just have ln of x plus 6 over x minus 4 is equal to ln of x. Now since they're the same logarithms on each side, both ln's, and they're both equal, that means what's on the inside has to be equal. X is equal to x plus 6 over x minus 4. Let's get rid of the fraction by multiplying by x minus 4. So you have x times x minus 4 on the left hand side, and then x plus 6 on the right hand side. That would give us x squared minus 4x is equal to x plus 6. So if we subtract x from both sides and subtract 6, that would give us x squared minus 5x minus 6 is equal to 0. And if you're subtracting 6, or since we have minus 6, since we're subtracting 6, that means our factors would be different signs. So we want the factors of 6 that subtract to give us 5, that would be 6 and 1. And the bigger number would be minus, smaller number would be plus, since the sign's minus. So x is equal to 6 and x is equal to negative 1, or x is equal to 6 or x is equal to negative 1. But remember we said x must be greater than 4, so we don't care about the negative 1. So x is equal to positive 6. So now if I give you an exponential equation, you have 2x is equal to 5, and I want you to solve for x. It's kind of hard to rewrite 5 as a power of 2, like 2 to whatever power. But if you were to take log base 2 of both sides, since the x is an exponent with 2 as the base, if you do log base 2, those would cancel out, so you're left with x is equal to log base 5 of 2. You could leave it like that, or you could type that in your calculator and it would be approximately 2.32. So it's just log base 5 of 2, or approximately 2.32. So the next example, solve for x. 8 times 3 raised to the power of x is equal to 5. Now we cannot just multiply the 8 and the 3 together, because this is considered one term, 3 to a power of x. So we have to divide by 8, get the 3 to a power of x by itself. So you have 3 to a power of x is equal to 5/8. Now since 3 is the base, you can do log base 3 on both sides. So x is equal to log base 3 of 5/8. So here's another example. Solve 5 raised to the power of x minus 2 is equal to 3 raised to the power of 3x plus 2. Alright, it might help, since the x's are in the exponent, to take the same logarithm of both sides. For instance, if we were to take ln, the natural log of both sides, we'd have ln of 5 raised to the power of x minus 2 is equal to ln of 3 raised to the power of 3x plus 2. Since now both sides are in a logarithm, we can move the exponents out in front, so we have x minus 2 times ln of 5 is equal to 3x plus 2 times ln of 3. Since we're multiplying the parentheses by the logarithms, we could distribute each logarithm into the parentheses. And we would have x times ln of 5 after we distribute the first time. Then minus 2 times ln of 5 is equal to 3x times ln of 3, or 3 ln of 3 times x, whichever order you want to put it in, plus 2 times the natural log of 3. Now when we get the x terms on one side and the non-x terms on the other, and that would give us ln of 5 times x minus 3 ln of 3 times x is equal to 2 ln of 3 plus 2 ln of 5. Then, if we factor an x out of the left-hand side, that would give us ln of 5 minus 3 ln of 3 times x is equal to. Now, on the right-hand side, we could factor out a 2. So that would be 2 times ln of 3 plus ln of 5. So now, if we divide both sides to solve for x, if we divide ln of 5 minus ln of 3, we would have x equals 2 times ln of 3 plus ln of 5, the stuff that's on the right-hand side, divided by ln of 5 minus 3 ln of 3, which as a decimal approximation would be about negative 3.212. Or you could just leave it like this. It doesn't matter. Now, here's another example of solving an exponential equation. Solve 4 raised to a power of x plus 2 raised to a power of x is equal to, or minus 12 is equal to 0. It doesn't look like we can use exponentials, but let's see if we can rewrite 4 raised to a power of x. Alright, since 4 can be rewritten as 2 squared, we can write 4 to a power of x is equal to 2 squared raised to a power of x. Now, since we have an exponent raised to another exponent, we can multiply the exponents together, so that would be 2 raised to a power of 2 times x. And this, since we have 2 exponents being multiplied together, we can rewrite it as just one exponent being raised to the other, so that would be 2x raised to a power of 2. Since you have these exponents being multiplied together, it doesn't matter which exponent is being raised to the other one. Both of these statements would be equivalent. So we can rewrite our quadratic as, instead of 4 raised to a power of x, we could rewrite it as 2 to a power of x raised to a power of 2 minus 2 raised to a power of x minus 12 is equal to 0. So why don't we do a little bit of substitution, make it look like what we're used to. If we let u be equal to 2 raised to a power of x, we have u squared minus, instead of 2 to a power of x, we'd have u minus 12 is equal to 0. So now let's factor this down. That would be u minus 4 times u plus 3 is equal to 0, which means u is equal to 4, or u is equal to negative 3. Now, remember, u is just equal to 2 raised to a power of x. So instead of u equals 4, it'd be 2 to a power of x is equal to 4. And instead of u is equal to negative 3, it'd be 2 to a power of x is equal to negative 3. So if you raise 2 to a power of 2, you get 4. So in this case, x is equal to 2. But if you remember from previous videos, the range of the exponential function is always positive, which means we can never have a negative y value. Not unless we do some sort of transformation on the graph. But since this is the parent exponential function, it is just 2 to a power of x. That means the y values all have to be positive, which means we don't care about this, so x must be equal to 2.